Hey everybody, welcome to Algebra 1-2, Section 12.3, Measures of Central Tendency. Now you might know that terminology better as mean, median, and mode. So, by the end of this lesson, you should be able to know how to calculate the mean from a set of data, know how to calculate the median from the set of data, and calculate the mode from a set of data. You should also know when to use each one appropriately. If you look at a set of data, how do you know which one best represents all that data? Finally, you should be able to know how to calculate a missing piece of data in order to achieve a desired mean. So let's get into interpreting data, mean, median, and mode. Because sometimes we have data and it's just a little bit of data. And so if we have something like this talking about the height of tomato plants, we can look at those numbers and there's not a whole lot of numbers there. So we can kind of get a sense for how tall these plants are. Other times you have data and there's just so much data, it's like, how does that all even make any sense? So we have to kind of take this data and kind of compute it and kind of figure out, okay, what does this overall mean? What's the central tendency? There might be a few cases that are kind of out there, but overall, what's the general theme of what's going on with these numbers? And there's lots of ways of doing this, but the three most basic ways are mean, median, and mode. So let's take the tomato plants and let's go ahead and figure out the mean, median, and mode for each of those. So let's take just the numbers, let's move it out of the way a little bit, and now let's talk about mean. Now you probably know this, and hopefully this should be a review lesson for you, but mean means average. And of course, anytime you want to average something, you add up all the numbers and then divide by how many numbers are there. So if we add all those up, and it looks like there's a total of 8 numbers, we would get 350 over 8, which turns into 43.75. So that means on average, each tomato plant is about 43.75 inches tall. So now let's talk about median. For median, what you have to do is you have to get all the numbers in order first. So I've gone ahead and done that. If you've got lots of data, sometimes that takes a while. But all you have to do is just find the number in the middle. So what I like to do is once I get the list in order, go ahead and cross off the biggest and the least, and then the next biggest, next least, and just keep on working my way down to the center. So I'll do that on the two ends, and then do it again, and do it again. And I finally get to the center, but instead of having one single number there, there's 2 numbers there. Okay, if I were to cross those off, I wouldn't have anything left. So to find the median, if there's 2 numbers in the middle, you just add them up and divide by 2. So basically just average those 2 numbers. So if I add them up, I get 86, divide that by 2, and I get 43. Now what the significance of the median is it tells you that half the plants were smaller than 43 and half the plants were bigger than 43. So that's why the median is important, because it lets you know half the people did below this, the other half did above that. Okay? So now we know the mean, the median. Now let's find the mode. For the mode, you don't have to have the numbers in order, but it kind of helps, because if you put the numbers in order, you can kind of see groupings. But what the mode is, it's the most frequently used piece of data. So I'm looking for any duplicates here, and I don't see any duplicates. So I would have to say that there is no mode here. There's no one value that stands out as occurring more than any other. All right, so let's go ahead and take another look at some data here. These are numbers that I just made up. So 1, 16, 16, 17, a bunch of 18s, a bunch of 19s, and a bunch of 20s. So if this were like quiz scores and it was out of 20, I'd say overall this class did very well. Okay? So let's figure out the mean, median, and mode for each of these. So for the mean, let's add all those up. And since there's 15 scores there, let's go ahead and divide by 15. So 258 divided by 15 is 17.2. Now let's go back to the original list and do the median. Let's start crossing off numbers until we get to the very center and there's a single number there. That's my median. That tells me that half the people did worse than 18, half the people did better than 18. Okay, so if this is a 20-point quiz, if half the people did better than 18, I'm pretty happy with that. Now let's take a look at the mode. So look for any duplicates. So 16 has a duplicate, 18s have duplicates, 19 has duplicates, 20 has duplicates. Now, how many is in each group? Well, it looks like because 18 has 4 and 19 has 4, it looks like those are our modes. So I would say that the mode is 18 and 19. Normally, you're looking for the one number that occurs more than anything else. So if there was one more 18, then we would say 18 is the mode. If there was one more 19, we'd say 19 is the mode. But since 18 and 19 have the exact same number, we can say that this is bimodal, and we have two modes, 18 and 19. Now, if you have three modes, then it's not like any one number is kind of standing out, okay? So it can either have no mode, it can have one mode, or it can have two modes, but it can't have 3, 4, or 5, okay? We're looking for the one or two values that stand out above every other value. So now if we take a look at that data, again, if these were the quiz scores for a quiz out of 20, if kids are getting 16, 16, 17, a bunch of 18s, a bunch of 19s, a bunch of 20s, I'm very happy with this quiz score. But which measure of central tendency best represents what's going on here? So the mean is 17.2. Do I look at this and think, the average score was a little over 17? No, a lot of people did great. The median, half the people did better than 18, half the people did worse. Okay, I'd buy that. The mode, 18 and 19, yeah, I think that's a strong representation of what we have here. But why is the mean so off? Okay, so it's because we have that one person who got a 1 on the quiz. And that's what's known as an outlier, one score that doesn't really fit with the rest of what's going on here. So again, when we talked about this earlier, we said we try to find the measure of central tendency. With all this data, what's the main theme going on? And you might have one or two people who's kind of out doing their own thing. Those are called outliers. So here's another example. Let's say we had a test, and those are the scores. Some person got a 1, and then 4 people got a 99 on this test. So if I do the mean, it's 79.4. And I'm just going to go through this real quick just to prove a point. The median would be 99. The mode would be 99. So which best describes the data? I'd say the median and mode do a great job of describing the data, but the mean does not. Because that one outlier, one person got a 1 on that test, that bombed the entire average. So how do you know which thing works the best? So it's best to use the mean if there's no outliers in the data. If everyone's kind of around the same spot, then yeah, just use the average. You want to use the median if there is an outlier, because that one outlier can kind of tank the whole average. So if there is one, use the use the median. And it's best to use the mode if what you're looking for is non-numeric. So for instance, if you take a survey and you ask people, what's your favorite color? Or what month were you born in? Obviously, we're not going to be able to take the average of that. We're not going to be able to take the median of that. You know, how do you organize colors in order? You know, so when the data is non-numeric, that's when you want to use the mode. Okay, so kind of take a screenshot of this or write this down in your notes. How do you know which one to use best? There you go. Last skill I want you guys to learn is how to find missing data. So for instance, if Cameron has test scores of 40, 78, and 72, what's the lowest test score he can get on the 4th test and still have an average score of 60%? So with questions like this, I see people mess up all the time. So I'm going to show you a few of the big pitfalls that happen in problems like this, as well as the right way to do this. So some people will sit there and say, okay, so it wants an average, so I'm going to add up what I got and divide. So I'm going to add up those 3 numbers and then divide by 3. No, that's not what's going on here. Because you're trying to figure out what's the 4th score. So you don't have 3 numbers, you're actually going to have 4. But what I'm going to do is I'm going to put all those numbers that I have plus x, that 4th score that I don't know yet. And as soon as I put that plus x in there, I no longer have 3 in the denominator, but I have 4 in the denominator. So that's the first step, is get a setup like this, showing that I'm averaging 4 scores. And so I put that x in there as the 4th score and then put 4 as the denominator. And then what I'm going to do is I haven't touched that 60% yet, because this average that I already have set up, that is going to equal 60. Now that's a good equation. Okay, so take a look at that, make sure that that makes sense. And now let's talk about how to work out that equation. A lot of people will look at this and say, well, you add up the three numbers, and yeah, that's not bad. Okay, let's add up those three numbers. And so when I add up those three numbers, I get 190. And then some people will say, okay, so I've got the 190, and if I divide that by 4, I get 47.5. And that is the wrong way to do that. Because that 4 is not just dividing the 190, the 4 is dividing everything. So rather than take that 190 and divide by 4, again, don't do that. Once you add up all those numerators in the all those numbers in the numerator, what you want to do is you want to get rid of the fraction. So let's multiply by 4 on both sides. And then I get 190 plus x equals 240. And doesn't that make sense? If his average score is going to be 60 and there's 4 tests, wouldn't that give him a total of 240 points? So he's already earned a total of 190 points, and he needs to earn a total of 240 to get that average of 60. So you subtract, and he can get by with a 50% and still have an average of 60. Okay? Let's do one more example like this. So let's say you're given those 5 numbers. What is the 6th value that would make the average 9? So let's make sure that we get a good setup. Take the 5 numbers plus x and divide it by 6. And then since we want the average to equal 9, we'll put equals 9. And now we can go ahead and do 2 things at the same time. Let's go ahead and add up all those numbers. So 10 plus 8 plus 7 plus 4 plus 3 is 32. And while I'm at it, can I just go ahead and multiply that 6 to the other side and make that equals 54? Okay, it doesn't really matter which thing you do first, whether you add up those numbers first or multiply by 6 first, or you can just do them at the same time. So now that I've got that, I've got a very easy equation. All I need to do now is subtract 32, and there we go. My 6th value would have to be 22 in order to make each average 9. And that kind of makes sense because of all these numbers, 10 is the only one above the average. Everything else is below. So I'm going to need a much bigger number to get all those other numbers up to average. All right, so hopefully mean, median, and mode was kind of a review for you. But I think this last topic of finding the missing data might be something a little bit new, and it might be something we have to work out a little bit. But overall, I hope that you guys found this lesson easy and doable. If you guys have any questions, please let me know either in person or via email. I'd love to help you in any way possible. So I hope you guys are doing all right. Take it easy, and I'll see you real soon. Have a good one.